So we talked a little bit about radicals last week. We know that when we have those rational exponents, so if the exponent is a fraction, that is equivalent to having a radical. And when you do that, the denominator of your fraction is what's called the index. It's that small number outside our radical. So first thing I have, my first slide is just kind of that refresher. If I said x to the 3/5, that's written in exponential form right now because it has an exponent. If I ask you to write it in radical form, that means write it so we have a radical. What would that be? Which number goes out here? The denominator. So 5, so we call it the 5th root. And you can either put the cube under the radical or outside. Okay. I'm not going to require you to write me both, so it's an either or thing. Either of those would be fine. All right, if I said the 7th root of y to the 10th, and I wanted that in exponential form, that means exponential, you write it with an exponent and not a fraction, so that would be y to what power? 10/7, the 10/7 power. So, exponential form has the exponent, radical form has the radical. Let's practice reducing radicals. We're used to just thinking a square root and a square kind of cancel each other. So if I see this one, it's really tempting to just say, oh, square root and square cancel, my answer is -7. But if I actually worked it out, what is -7 to the 2nd power? So that means -7 times -7. What would that give us? And what is the square root of positive 49? 7. So you do have to be a little bit careful there. When you square it, the negative will go away. And when you do the square root, you do get the positive. If I look at this one, the cube root, when I'm looking at the inside, the radicand, this is all one term. So we can just take the cube root to each piece. What is the cube root of positive 64? All right, with our variables, there's 2 ways of thinking about it. If we were doing it, just kind of thinking through your radicals. You have 6 a's. The cube root means how many groups of 3 can we form? So if you have 6, how many groups of 3 do you get? 2. If you have 15 b's, how many groups of 3 can you form? 5. This is very closely related to how we are working these problems last week. If I had given you this problem last week, you would have said a cube root is a 1/3 power, and then you would have taken that 1/3 to everything. 64 to the 1/3 is 4. With these exponents, you would multiply. 6 times 1/3 is 2. 15 times 1/3 is 5. So it doesn't matter if you want to write it in exponential form and simplify it there, or if you can kind of think through the radicals. It's just like dividing those powers. 6 divided by 3, 15 divided by 3. what's going to happen with this negative? Yep. It's not under the radical, it's just trailing along. Okay, what is the 4th root of 625? 5. What is the 4th root of 81? So it's a negative 5/3. Does everyone know how to do those radicals on your calculator if you need to? You'd have to type in the 4th root first, so you'd hit 4 and then go math number 5 if you have one of those graphing calculators. Right, I'm going to put a few problems up that I want you to work. So take a second and see. Oh, shoot. I probably don't want you to do these. These aren't totally nice yet. I'm going to add a couple on here that I want you to do. Alright, what is the 5th root of negative 32? And then it would be x to the y to the 4. It's just 10 divided by 5 is 2, 20 divided by 5 is 4. Okay, e, the negative on the outside stays. What is negative 9 squared? 81. What is the square root of 81? And then the square root of a to the 10th? Alright. Are those okay? Let's move on. So let's say I gave you this problem. The 4th root of 32. If you type that in your calculator, the 4th root of 32, do you get a nice answer? No. I do not want decimals pretty much throughout the year. We are going to get the most exact answer we can. Okay, so we don't want to round a decimal. Think about things to the 4th power. So what is 2 to the 4th power? 16. Can you do 32 divided by 16? Yeah. If not, we would go on to the next one. So we can rewrite 32 as the 4th root of 16, and 32 is 16 times 2. Okay, so we're going to kind of break that up. The 4th root of 16 is 2, because 2 to the 4th equals 16, but I cannot do the 4th root of 2. So my answer is 2 4th root of 2. Cube root of b squared over c to the 9th. Alright, can I do the cube root of b squared? No, it's cube root. We have to have 3 of them to break it out. I only have 2, so that's just going to stay. Okay, what is the cube root of c to the 9th? C to the 3rd. 9 divided by 3 is 3. If you have 9 c's, you can make 3 groups of 3. So sometimes we are not going to be able to completely get rid of our radicals. We just have to break them down as much as we can. Let's see. down 18. Perfect square that goes into 18. The negative on the outside just stays. Square root of 9 is 3. I can't do the square root of 2, so it stays. If we have 5 x's, how many groups of 2 can we form?
2.
Are there any x's left over?
4.
So 1 x remains under the radical. Okay, does everyone see why that is? Okay, so if you have 7 y's, how many groups of 2 can we make? 3. And then there would be 1 left over. 2 groups of 3 would use up 6 of the y's, and we had 7. This is all one term because there's no addition or subtraction, so we can just take the radical to each piece. If you have 7 a's, how many groups of 4 can you form? 1. How many a's would be left over? 3 left. If I have 10 b's, how many groups of 4?
2.
How many left over? 2. Okay, that's the top. On the bottom, if I have 8 c's, how many groups of 4? 2. Are there any left over? No, so the radical goes away. I want you guys to try a few problems. No, so we have to break it down. What number goes into 24 that is a perfect cube? 8 and 3. So the cube root of 8 is 2, so 2 comes out. I cannot do the cube root of 3, so it stays underneath. If I have 5 a's, how many groups of 3 can you form? And how many were left over? So 2 stay underneath. All right, if I have 10 b's, how many groups of 3? And how many left over? Questions on that one? B, I need something that is a perfect fourth power that would go into 48. 48 is 16 times 3. The fourth root of 16 is 2, so that comes out. I cannot do the fourth root of 3. Also, make sure, you'll notice when I write the fourth root of 3, I write it like this. Don't write that. What would this mean? If you write a big 4. 4 times the square root of 3. This is the fourth root. So make sure your index is a small number up there. All right, if I have 9 x's, how many groups of 4 can we form? 2. So 2 x's come out, and there would be 1 left over. If I have 12 y's, how many groups of 4? 12 divided by 4 is 3, and there were none left over. So that's my answer. C, I need a perfect square that goes into 50. What would that be? So the square root of 25 is 5, so 5 comes out. We still have the square root of 2. If I have 1a, is that enough to do a square root of? No, we can't form a group of 2, so that just stays. If I have 5 b's, then we can make how many groups of 2? 2 with 1 left over. Okay, on the bottom, square root of 9 is 3. If I have 20 c's, how many groups of 2? 10 and none left over. All right, how are we doing on these? Did you guys remember doing this in the past? I want to try some different problems. Just using what we might know about exponents and radicals, seeing if we can simplify some different things. Okay, so the square root of the cube root of 27. So when I look at this, radical is kind of like a parenthesis. You start on the inside. When I'm looking here, my very inside thing is the cube root of 27. So if you have nested radicals like this, you just start on the inside one. I'm not worried about the square root yet. Can we do the cube root of 27? And that is a 3. So since it was a perfect cube, that radical goes away. Can I do the square root of 3? No. So that is my simplified answer. So if you have multiple radicals, just start on the inside and work your way out. All right, B. These radicals are multiplied. How do you multiply with radicals? Not really trying to be a trick question. Think back to when we were breaking them down. We said, well, 48, that's 16 times 3, and we broke those apart. So if I want to put them back together, you just multiply these numbers. 16 and 3 gave me 48, and the radical doesn't change. So if they're both under the same radical, we can multiply them together, and it just becomes under one radical. So 6 times 7 is 42. A times A will give me A squared, and then we have a B. Now let's see if we can reduce. 42, is it divisible by any perfect squares? Perfect squares, you can't divide by 4, 9, 16, 25, 36, and there's nothing else smaller than 42. So we can't break it down. If I have A squared, what would come out? And A comes out and none left over, and we only had one B, so it just stays under the radical. What are we being asked to do here? So if we FOIL these, you multiply the numbers outside the radical together and the numbers under the radical together. So 2 times 3 would give me a 6. Square root, and then 5 times 5 is 25. Outside. The 1 does not have a radical, so you just take the 1 times 3, which is 3, and the radical 5 stays. Inside. Negative 2 times 2 is negative 4, the radical 5 stays. And last, negative 2 times 1 is negative 2. But we can simplify here. The square root of 25 is 5. So this means 6 times 5, which would become 30. When you are adding radicals, or adding or subtracting, it's just like any other thing. You can only put them together if they have like terms. Like terms means the same thing under the radical. So both of these have a square root of 5. We combine them by adding the coefficients. So positive 3 and negative 4 is a negative 1 radical 5, or just negative radical 5. And we have that minus 2. So then 30 minus 2 is 28 minus the square root of 5. last one. What did I just tell you we had to have before we could add or subtract radicals? Like terms. And what makes them like terms? The number under the radical has to be the same. So if I'm looking, these are all cube roots, but we have three different numbers, 16, 54, and 2. So these are not like terms as it stands right now. I cannot just put them together. So we start by seeing, can I reduce any of these? So the cube root of 16, do any perfect cubes go into 16? Okay. What is the cube root of 8? 2. So what this means is really 5 times 2 times the cube root of 2, or 10 cube root of 2. So we said 16 is cube root of 8 times cube root of 2. Cube root of 8 is 2. All of that was multiplied together. So when you multiply the 5 and 2, you get 10. Right, if I look at the next term, I had a 3. Cube root of 54, what can we break 54 into? 27 and 2. So this means 3 times the cube root of 27 is 3 times the cube root of 2. 3 times 3 gives me a 9 cube root of 2. So if you have a coefficient when you're breaking down those radicals, it gets multiplied with the coefficient that was already there. 4 cube root of 2, can we break that down at all? No, so that just stays. But now if we look, every one of these has a cube root of 2, so we combine the coefficients. 10 plus 9 plus 4, and the cube root of 2 does not change. Alright, this is where I'm stopping today. Tomorrow we are going to talk about rationalizing, getting the radical off the denominator. So, couple things. Math Excel, I pulled it up and I looked. Several of you have a few problems left. That's due by 3 o'clock today without a late penalty. So make sure you get that done. That would be your top priority. Second thing, I posted a handout on Google Classroom. This is for today and tomorrow. But actually, you're ready to do almost all of it right now. I think everything except maybe the last 4 problems. So you can start this. It won't be collected until Wednesday. So finish Math Excel if you have not. Begin this handout. Tomorrow we'll finish this section and probably do a few review